Hello, welcome to Lenze training. This tutorial shows how to set up electrical shaft application in i950 using System Bus, and run the axis from controller using Fieldbus. i950 drives have two types of EtherCAT connection possibilities. One is onboard EtherCAT communication interface and the other one is Fieldbus EtherCAT interface. For central motion topology, that means for applications where logic and motion both are in PLC, we must use EtherCAT onboard. Remember, i950 could only be synchronized via EtherCAT onboard, cause EtherCAT onboards only has DC synchronization to the application in the drives. The i950 TACF402 or TACF402 Advanced are made for central motion topology. In the decentralized topologies, where central logic is inside the PLC and motion functionality is inside the drives, we could use either EtherCAT onboard or Fieldbus EtherCAT, Profinet or Ethernet IP modules at the drive. If synchronized motion control is to be set up between several drives in the decentralized topology, the logic communication to the master controller must be done via the Fieldbus modules. The electrical shaft functionality can thus be implemented via the EtherCAT onboard. In this case, the System Bus functionality of the i950 drives provides the synchronized motion communication between the drives. Applied to our application, we use the EtherCAT onboard as the System Bus for decentralized motion control with electrical shaft function. The logic control of all i950 drives is done via the EtherCAT Fieldbus modules. Here in this project, two online devices are present. We will prepare electrical shaft application using i950 System Bus. By default, initially onboard EtherCAT interface mode set to slave for all the devices. Network status indicates the bus status of the onboard EtherCAT. Here we will configure rotary axis as master. To do so, change the onboard EtherCAT interface mode to master. Save the changes to device. To make these significant changes effective, restart the device once. To restart the device, go to Parameter List. Under the menu Administration you will find several device commands. Choose Restart Device from the menu and select on Start. Now, go back to Onboard EtherCAT menu after restarting the device. You will see Active Interface Mode change to Master. New Restart button appears on the right side, through which you can restart the communication if required. It also shows the EtherCAT master state. Now it is in operational state. Let's go to System Bus. System Bus input and output data are visible here. In the matrix below we can assign the process data transfer in the network. The source selection of the first four double words, the cycle length, position, velocity and acceleration, applies to all nodes on the System Bus. The sources for torque, timestamps and TA-specific values can be assigned differently for each node in the network. Please note that this assignment is exclusively done in the System Bus master. Now we need to configure the TA interface and master value sources. For this go to the TA sync and correction overview and choose the master values. In our topology the TA interface switch remains on Fieldbus, because the logic control is connected on the EtherCAT Fieldbus module. Set master value source as virtual master. At the system bus master output, we can define which set point or actual value is forwarded on the network. We also leave the default setting here and transmit the virtual master value. If we go back to system bus now, it will show system bus output cycle length as 360, which is the cycle length of virtual master. The identical cycle length must be set in the slave drive so that no additional transmission ratio is effective. Now we will configure the following axis, that is box conveyor axis in our case. Go to TA sync and correction. Keep TA interface switch as Fieldbus. Same for master value source. Keep the system bus. There will be no master values output, so you can select none from the available options. When we call up the system bus menu in our slave drive, the cycle length of 360 units transmitted by the master drive is already visible at the system bus input. Let's double check the cycle length in our motion settings. Save your parameter settings into all devices. Now, we can say two drives are now connected via system bus. For machine control, we have created a sample program for the connected C300 controller. In the main program, we have declared two separate instances of the sync and correction function block of the technology application, which we will use in our program. Further function blocks for technology applications are also available and can be used as required. Under the device EtherCAT master, you can see two Fieldbus i950 device are configured. The Fieldbus description also shows the active TA application in the device. We have renamed axis name same as in Easy Starter for better understanding. In the main program, we have assigned respective axis with the desired function block. In addition, we have created a separate visualization for the control of each device. This visualization template is built-in and can be found under Visualization Toolbox. Each TA has its own visualization template. Now go online with the controller. First, we will set necessary parameters for box conveyor axis, which is a slave in system bus. Enable the internal control. Enable operation for the drive. Execute homing. Sync in the device. Next, we go to rotary axis visualization. Master values output system bus, which is set as virtual master, configured in rotary axis. So, we will now set virtual master velocity. Turn on internal control. Enable operation. Execute homing. Set VM velocity, for example 180 unit per second. Sync in the rotary axis. Now start the motion with command VM continuous. It will start rotating both the axis continuously with the speed set point. Here you can see motion has already been started. Now, let's go back to the Easy Starter. We can go to the monitor window of the online devices. Here you can see both devices are running synchronously, as required by the electrical shaft application. System bus window of the master device shows the system bus output command. For the slave device, same data is visible in system bus input side. In this way we can realize an electrical shaft application with a system bus, using the EtherCAT Fieldbus as a logical interface.